We previously discussed qualitative and quantitative risk factors. We also stated that the asset value is a factor that must be considered when conducting quantitative risk analysis. Another factor that must be considered is the exposure factor, or EF. The exposure factor represents the percentage of loss a realized threat could have on a certain asset. The exposure factor is a subjective value that the person assessing the risk must define. If the asset is completely lost, the exposure factor is 1.0. Another variable we must consider is the single loss expectancy, or SLE. The SLE is a dollar amount that is assigned to a single event that represents the company's potential loss amount if the specific threat were to take place. To calculate the single loss expectancy, we simply multiply the exposure factor by the asset value. In other words, AV times FE equals SLE. So let's take a look at a real-world example. Let's suppose that we expect a hurricane might damage 25% of our data center. We would set the exposure factor to 25%. If the data center is valued at $40 million, or in other words has an AV of $40 million, we could calculate the single loss expectancy for SLE by multiplying 40 million by 0.25. In this case, our single loss expectancy would be $10 million. Interpreted another way, this implies that a single hurricane would yield $10 million worth of damage to our data center. That's the impact of risk. The SLE, however, only gives us an idea of impact. As previously discussed, risk assessment must also consider the likelihood of a risk, and that is where ARO enters the equation, which we will discuss next. Now that we are familiar with the asset value, the exposure factor, and are able to successfully combine it to determine our single loss expectancy, let's take a look at some other important risk factors to consider. The annualized rate of occurrence, or ARO, is the value that represents the estimated frequency of a specific threat taking place within a 12-month time frame. The range can be from 0.0, or in other words, never, to 1.0, in other words, once a year, to greater than 1, several times a year, and anywhere in between. For instance, if the probability of a fire taking place and damaging our data warehouse is once every 10 years, the ARO value is 0.1. The annualized loss expectancy, ALE, is the product of the annualized rate of occurrence, ARO, and the single loss expectancy. A risk analysis should incorporate both the likelihood and impact values. In this case, the impact of risk is expressed in terms of SLE, where the likelihood is expressed in terms of ARO. Multiplying SLE by ARO gives us an annualized loss expectancy of $100,000. This means that we should expect to lose $100,000 each year. It's important to remember that in reality, this cost wouldn't occur each year. What we really would have happen is $10 million in damage each time the event occurs. But since the occur happens only once every 100 years, it averages to only $100,000 a year. And that is quantitative risk analysis in a nutshell. Once we've performed quantitative risk analysis, we can more accurately assess our ability to restore IT services and components quickly in the event of a failure. To do this, we need to consider two things. Specifically, we want to know if the asset is non-repairable or if it's repairable. If it is a repairable asset, we consider the metric of mean time to failure, or MTTF. The mean time to failure is the amount of time we expect will pass before an asset fails. If the asset is repairable, then we can look at two different values. The first is the mean time between failures, or MTBF. The mean time between failures is simply the average amount of time that passes between failures of a repairable asset. The second value we look at for repairable assets is the mean time to repair, or MTTR. The mean time to repair is the amount of time that an asset will be out of service for repair each time that it fails. If we consider both the MTTR and MTTF values together, it provides us with a better understanding of the expected downtime for our services and components.